Hello everyone, very good morning. I am Devashish Das from University of Kolani, India. In few months ago, we started some on study on survey on security issues in intelligent transportation system and automobile sector, and therefore we focused on deployment of blockchain technology in intelligent transportation systems. Basically vehicle security, vehicle communication, secure platform, etc. And this is a part of work, and this entitled design of an automated blockchain enabled vehicle data management system. This is our roadmap, what I will going to discuss. Today, Internet of Vehicle have the massive potential to communicate with each other using sensor, communication device, and computing device. But there are still challenges like device security, sensor data manipulation, communication security, and private safety issues in vehicular network, and therefore there are another important thing is the data security is most important for the automated vehicle management systems. However, in this existing system, each message contains some sensitive transportation data that should be authenticated to maintain the integrity of the systems, but data can be manipulated or stolen by malicious hackers or users in vehicular networks, so that can be compromised data privacy as well as data security. Therefore, we need to provide some data authentication process and like mechanism, data verification mechanism, and secure database management systems with data immutable data storage, and that's why we take blockchain as a tremendous technology which can enable automated data management using smart contracts in this proposed work. And in this proposal, any unauthorized authorities cannot access data, and therefore the user privacy, security of vehicles will be improved. The existing issues in vehicle data management systems are user privacy, platform security, data transparency, authentication, verification, and data security also. In this proposed work, a data management framework is proposed which is automated using blockchain and smart contracts for the vehicle security as well as vehicles privacy, user privacy, data security, and platform security. An automatic data upload mechanism is proposed by the user. In this proposed system, user can upload data automatically through the blockchain API, and therefore this data should be verified by some authorities, and this data can be accessed by another authorities for the future case. The proposed drug also provide unauthorized access detection to personal data, unauthorized access detection to vehicle, unauthorized access detection to the user interface. This is the proposed system model, and here some entities are taken like vehicle user, data verification authority, and data access authority. Vehicle user create an account into the blockchain network to get access the proposed works features, and they should be authenticated using smart contract, and user also can upload data and these data should be verified physically or virtually by the data verification authority. After successful verification of data, these data should be uploaded to the IPFS server through the blockchain transaction execution, and these data can be accessed by some another authorities like data access authorities through user consent. After if user allowed to access this data or requested data, then smart contract are allowed to access the data by the data access authority. Therefore, this system is an automated where user upload data and data verification authority verified data to provide the trust application here, and data access authority can access data automatically through the smart contracts, and before all the features are activated, all the entities should be verified using entity authentication process that will be provided here. This is the implementation process. First of all, entity authentication. Entity means vehicle user, data access authority, and data verification authority. Data uploading mechanism also, the user should be verified before uploading the data to the blockchain. And data access mechanism, authorities can access data by giving the correct authentication token that should be provided in the entity authentication process that was accessed and authenticated in the entity authentication process. This is the flowchart of data accessing mechanism. Here, if the entity here EA is equal to success, that means entity authentication successful is status. Entity authentication status is successful. Therefore, data verification authority can verify the data, and DAA request to access data. Data access authority want to access data. Therefore, if the trust value of data is validated, therefore the data should be trusted or authenticated. Therefore, DAA can access data through user consent by the smart contracts authentication process. This is our entity authentication algorithm: successful authentication or reject authentication. This is the experimental setup. We used several tools like VS Code, GainH, Remax, Web3.js, Truffle, React.js, and Node.js. Node.js and VS Code basically to deploy environment and execute code execution. And GainH is a blockchain server, local server. Remax is the ID to develop smart contract. Web3.js is a interaction between background and foreground applications, and React.js is the user interface that we can see in the API. This is the account creation process. User can data access authority, data verification authority and data access authority can authenticate and create account and authenticate himself. Data uploading mechanism interface. Here user can upload data, and this is the authority blockchain account address, and upload data. After data uploading, user can access data. Here I can see the data, uploaded data. And data accessing scenario, here data access authority can provide the user details or data details like data hash or data number, anything they can, that should be identified uniquely that this data is required for the data accessing authority, and they can access data through user consent. Whenever they request to they can submit request to access data, and therefore these requests should be sent to the user by the smart contract. And if the user want to allow, then therefore data access authority can access the data. So all over process is the automated. So blockchain, as the blockchain is a low risk technology and it can provide immutable data storage, it can provide data security, and for the vehicles data or as well as user data whenever. And first of all, we need to secure the authentication and verification process to keep data secure and safety. And we provide user authentication process, like here entity authentication process, entity verification process, and data validation, trust value generation, etc. And therefore we can say that this automated blockchain enabled data management system can provide data security. And automatic vehicles user authentication also provide here, and vehicle user has predefined rights to their data to manage their data through entity authentication process, and based on the different authorities connected in the blockchain network. So we can say the proposed framework provided a secure authentication process using successful authentication and rejection process. And also if the data is secured, therefore we can say the user privacy also provided using data verification and validations. So all the process are managed by the smart contract that is stored in the blockchain. Therefore no can manipulate the predefined rules or smart contract code without user consent or with user consent. So this is the blockchain's intrinsic features that is very innovative and secure for the any applications. And we provided this blockchain technology in the intelligent transportation system for vehicle data management system. This work can be extended to in the vehicle communication process that is not here, that is not present in this work. Trusted communication, how how vehicles can trust with to get or send received to send and receive data in the communication process automatically through the blockchains and smart contract. That could be worked in future. And therefore global communication among vehicles running on different roads can be developed to enhance the reliability of intelligent transportation system or intelligent traffic management, where vehicle can know the situation or situation what types of vehicles are present in different roads, and they can know the which way they can go, and therefore they can get efficient way to travel without traffic jam or without any issues. This work can also be extended for autonomous vehicles, where autonomous vehicle, and it is very important to autonomous vehicles require some automated functions. Basically these functions can be developed using AI, machine learning or another. And this work can be extended to the cyber physical system to communicate vehicles with uh, petrol pump or parking systems or another way. This is some differences. Thank you.